Hi, my name is Arifa Adelacimo, and I'm making this video today to tell you about a wonderful opportunity you have to invest in yourself and your own future career goals by enrolling in Matthews Tutors. I'm currently a freshman student at Columbia University in the city of New York, an Ivy League institution, where I am studying neuroscience and behavior on the pre-med track. I personally don't believe that I would have had the ability to call myself a Columbia student had it not been for the efforts of Matthews Tutors all those years ago. When I was in high school, I struggled with math, and I knew that I struggled with math. Math filled me with fear, and I wasn't confident doing it. But after just a few sessions with Matthew's tutors, not only was I instilled with the confidence to go forth in whatever math classes I chose to take, but I was able to increase my ACT score by almost 10 points, helping me earn a super score of 35. With those numbers, I was able to get accepted to all 16 colleges I applied to, including, but not limited to, Cornell University, Georgetown University, Tulane University, Duke University, and the college I currently attend, Columbia University. Matthews Tutors is going to do everything that they can to help you. That's what they did for me. But not only are they going to help you be a better student, they're going to continuously check in on you. I know that I personally received a lot of messages of support from them during my first semester of college, which was one of the hardest semesters I've ever experienced as a student. Matthews made sure that I had the confidence to go forth and pursue my own academic goals, but they also helped me increase the numbers too so that I could get where I wanted to be. And I know that they can do the same thing for you if you give them a chance. Thank you.
Hello, Unduka here from Matthews Tutors. I'm here to announce a special campaign that we're about to kick off. It's the 5,000 Students for Math. Here's what the campaign is about. We want to find 5,000 students that fit into any of these categories. Are you a student struggling with math today, or a parent of a student struggling with math today, and you want to help build confidence in your students' math abilities? The campaign is for you. Are you a student that is actually feeling comfortable about math, but you want to go a bit higher? You want to build your confidence level a bit higher? This campaign is for you. Are you an excellent student, but you need a challenge? This campaign is for you. We want to get 5,000 students so comfortable with math that they've built a good foundation for their future academic pursuits. Now, are you interested in joining us in this campaign? We invite you, we welcome you to join us in this campaign. How can you help us with this campaign? Share this video with as many people as possible, and we hope to see students sign up because we want to see every student become comfortable enough with math that they conquer their fear of math. Please join us, and I'm sure you will enjoy the result of this campaign. Thank you. Good afternoon, happy Sunday to everyone. I hope you're doing well, you're enjoying your weekend. I hope you've had a great weekend. I know tomorrow is Labor Day for those of us in the United States. I hope you're planning to rest some barbecue time. So what we wanted to do was just give you something, some math just from the week, and just I know as students are getting ready for school, They're, Algebra 1 geometry, Algebra 2 students are probably having to refresh their memory on things like quadratic expressions, quadratic equations, and I know some of our students are preparing for the SAT and the ACT, and those are topics that I know can be challenging. So I wanted to just spend some time with the students and just walk through several problems on quadratics. We're going to look at expressions, we're going to look at equations, and then I just threw in some word problems because that tends to be the area that throws students off quite a bit. So before we do that, I just want to let you know that as we're getting back to school, if you want some private sessions, we're still going to keep our free sessions going, but if you want more private sessions that are smaller and more focused on your specific needs, we have those options available. Just go to our website, mathis.com. You can email us at info@mathis.com, or you can also call us on any of these numbers that are indicated. So we'll just go ahead and get started with our topics. Before we start walking through topics, here is what I hope we can go through during this time. Looking at factoring quadratic expressions, we're going to look at the greatest common factor method. We're going to look at the box method and what I call the reverse FOIL as well. And then we're going to also try to solve some quadratic equations by factoring and then the quadratic formula. And towards the end, we will walk through some word problems, and I'll show you the simplest ways to really think through word problems, especially as they relate to quadratics. And just know that along the way you can ask questions. If you have specific questions, I know some are in Algebra 1, but most likely in Algebra 2 you may be reviewing quadratics, and there's some questions that you have that you really cannot figure out. You can always bring them and then we'll walk through them together. So we'll just get started with some of our questions. But before we get started with questions, these are some of the things I want you to know about quadratics. The standard quadratic expression and the standard quadratic equation, you can see that they look similar. The only difference there is that because it's an equal to 0, that is what makes it an equation. When there's no equal to sign, it's an expression. And then we're going to end up using this formula that is the quadratic formula. When we get to that point, I'll let you know. I'll probably state it again for you so that you can use that. So now let's go ahead and get started. Don't forget, if you have questions, just let them come through, and then I'll be checking the chat. Leave them in the chat. I'll check the chat, and if you have any kind of questions, I'll be sure to acknowledge them and see what we can do to help answer those questions for you. So here's our first question. We're going to factor this expression. I want to start simple. I think it's easier. It's always better to start with simpler questions so we can build up. So we're going to look at how to factor this type of expression. You can also go ahead and if you already have the answer, you can go ahead and post the answer while I'm walking through the questions. I'll go ahead and take a look at the chat, and I'll acknowledge if you respond. Even if your answer is not correct, I will acknowledge your response, because I think what I want you to feel comfortable responding to any of the questions that I pose during the session. So let's go ahead and start with our first question. So it's asking us to factor x squared plus 6x plus 8. So this is one of the simpler ones because the coefficient, which if you're not sure about what that term means, it just simply means the number to the left of your variable. Your variable is something like your x, your y, the z, a, b, c. Those are all variables. So your coefficient is the number to the left of your variable. In this case, we're looking at quadratic expressions that have where the quadratic term, which is this term with the x squared, the quadratic term has a coefficient of 1. So these ones are some of the easier ones to walk through. So I'm going to just teach you the simple tricks that you're going to have to go through to get through this. These methods they're very reliable. So when you have a quadratic expression or equation where your quadratic term has a coefficient of 1, here's what you're going to do. You're just going to go ahead and put your parentheses right here, and then you can just simply have your x, whatever your quadratic variable is, you have your x there. Now you want to find out two things. you want to find out the product of the coefficient of x squared, which is 1, and the constant term. The constant term is the term without the variable attached. So here's a variable, here's a variable. The constant term does not have a variable attached. So you're going to multiply by 8. So you multiply 1 by 8, which is going to give you 8. Now what you're going to do is you're going to look for the coefficient of the linear term, which is this one right here, which is 6. You want to look for the factors of 8 that give you a sum of 6. So with 8, it's probably easier to get to that factor, but here's what I typically try to do when I have this. I have 8, so I'm going to have 1 and 8, 2 and 4. So now I look at 1 and 8. Can I get to 6? No way, not from 1 and 8, but I can get to 6 from 2 and 4. But what do I need to do from 2 and 4 to get to 6? I need to add them. So it's going to be positive 2 and positive 4. So now what we have here, because we already have the factors, remember the rule is the product. If we actually have our quadratic expression, which is ax squared plus bx plus c, that's a quadratic expression. What we're looking for is the product of AC that give you a sum of b. That's all you're looking for. So here our product of AC is 8, our sum should be 6. The only thing that's going to give us that is 2 and 4. So now we're just going to simply have x plus 2, because that is this right here, and then x plus 4. So these are actually the factors of x squared plus 6x plus 8. Are there any questions? So the factors of x squared plus 6x plus 8 will be x plus 2 multiplied by x plus 4, or rather x plus 2 and x plus 4 are your factors. So now let's go to this one here. We're going to start. A good habit to develop usually is to start from ax squared plus bx plus c, and then you're going to have your AC here, and then you're going to have your b. So your AC in this case, remember your A, we can take the extra step of saying A is equal to 1, B equal to negative 8, and then C equal to negative 20. We can take that extra step. If you are learning, you probably want to do that. If you're already used to quadratics, you don't really need to do it because you know what you're working with already. So now we're going to multiply A and C together. That's going to give us negative 20. And our b is negative 8. So now what we're going to do is we're going to find two factors of negative 20 that will give us a sum of negative 8. So here's how we're going to go about that. Negative 20, because it's a negative number here, it tells you that one of your factors is going to be positive and the other factor is going to be negative. So I'm going to just do something here. Negative 20, I'm going to have negative 1 and 20. I also have 1 and negative 20. I can also have 2 and negative 10, negative 2 and positive 10. I could also have 4 and negative 5 and negative 4 and 5. So these are all the possible combinations, factor combinations that can get us to negative 20. So now we need to figure out which of these combinations is going to lead us to negative 8. But before we do that, let's get our parentheses ready. Our parentheses ready, we're going to put our x here and our x here. So now we need to find out which of these will give us negative 8. So in order to do that, you have to make sure that the larger factor has the negative sign. So I'm just going to get rid of these ones. The larger factor has to have the negative sign. So now we're going to figure out which of this is going to give us negative 8. We can see that this is going to be the right pair that is going to give us negative 8. So what we're going to do here is we're just going to say x plus 2, because that represents this, and then x minus 10. So these are your two factors of that quadratic expression. If you have any questions, please feel free to ask. I'm sure as we go further down, when we start looking at quadratic terms that have a coefficient of the quadratic, where we have coefficient of the quadratic term greater than 1. I think there may be some questions there because those tend to be a little bit more tricky. There are some things you have to do to make sure you get them right. So here we have an example. In this example, we're looking at 12x squared plus 7x plus 1. We want to find the factors of this quadratic expression using the greatest common factor method. So a lot of what we do for quadratics are pretty consistent. So I'm going to have ax squared plus bx plus c. And now we're going to find the values of a. So a here is going to be 12, b is going to be 7, and c is equal to 1. We have to still work with our AC and B. So we have AC equal to 12, and we have our B equal to 7. So now we're going to look for the two factors of 12 that give you a sum of 7. So here's what we're going to do. We have 12 here. I have 1 and 12. Because everything is positive, I'm not going to really worry about the negative part of, because we could have -1, -12, but that's redundant. It's not really necessary in this case because everything is positive. So we also have 2, 6, and then we have 3, 4. Okay, so now what we have in this case, we know that we want to find the product is 12 and the sum should be 7. This is the only group that is going to give us a product of 12 and a sum of 7. Now when we're looking at the greatest common factor method, here's a slight difference from the other method we're using. Whenever the coefficient of x squared or the quadratic term is 1, here's what we're going to do. And this is the main difference between the two approaches. So we have 12x squared, and for 7x, instead of just having 3 and 4, we're going to replace that with 3x plus 4x and then plus 1. So now what we do here, you can see that we have the same expression, only that we have broken down 7x into 3x plus 4x. So really, the expression hasn't changed. Now we're going to do what we call factor by grouping. So we're just going to group, this here and factor this. We're going to group this and factor it. So that's going to give us, let's look for a greatest common factor here. It's going to be 3x. So that's 3x. And then you divide every term in here by 3x. That should give us 4x plus 1. And then we look at this expression here, 4x plus 1. There's no the greatest common factor is 1 because you can't really find another number that can be divided by each of those terms. So this is going to be plus 1, and then we're going to have 4x plus 1. So now we have factored the groups, because we're factoring by grouping. So we factored each group. Now what you can see here is you have 4x plus 1 here, you have 4x plus 1. If you remember your greatest common factor, 4x plus 1 becomes the greatest common factor of this expression. So you're going to simply write it this way. 4x plus 1 is your greatest common factor, and you're just going to have the other factors, which is going to be 3x plus 1. So 4x plus 1 is your greatest common factor, and then what you have left is 3x and plus 1. So you combine them together, and these are going to be the factors of that quadratic expression. And just because of the greatest common factor, let me just spend a second just walking through that with you. So if I had something like this, if I had, let's say, 24 plus 48. So if we had to factor this, I would simply say 24, and then it's going to be 1 plus 2. The greatest common factor here is 24, and you can see that these are the other factors. In this case, you can simply add. But if we had an algebraic term, for example, we had something like 3x plus 6y, and then we have, so to factor this, your greatest common factor is going to be 3, and you're going to have x plus 2y. So it's the same concept that we have whenever we're dealing with quadratic expressions. Okay, let's go to the next. If there are no questions, if you have questions, remember, feel free to ask, and then we'll go to the next question. So we're going to do this also using the greatest common factor method. I wanted to do maybe 2 examples with this type just so that you can have an opportunity to see how it works. I think after this we're going to look at the box method, which is similar but is a little bit different in the presentation. So now what we're going to do is the same thing that we did for all the other quadratic expressions. What I want you to remember is quadratic expressions, to factor them, you always start the same way. Then where things start to change is when you have to figure out whether it's the quadratic term has a coefficient that is 1 or coefficient that is greater than 1. Sometimes if it's less than 1, you also do the same thing, but in this case we're focusing on those that are greater than 1. If you would like to solve, I'll try to give you a few minutes. I know we walked through an example already, so I'll give you a few minutes, maybe a minute or so, to see if you can solve it based on what we did earlier. If you'd like for me to go to the next, if you want to write this question down and you'd like for me to go to the previous page so you can actually follow the steps there, I can do that for you as well. But you always want to start with this: ax squared plus bx plus c. That's going to be your starting point every time you have a quadratic expression. So I'm going to look in the comments to see if anyone, if you're not even sure what to do, let me know. If no one has a clue, maybe I need to explain it differently, or I need to explain it again and use this example to explain it again. That's fine, we can do that. Okay, so we'll just walk through one step at a time, and then if you get lost as we walk through, just let me know that you got lost or you don't really get it, and then I'll go back and see how we can better explain to meet your needs. So the first thing we're going to do here is to find the values of a, b, and c. So in this case, a is going to be 5, a is equal to 5, b equal to -3, and c equal to -2. So now we still need to work with our AC and b. So a multiplied by c is going to be -10, AC equal to -10, and b is equal to -3. So now that we're at this point, we need to find the 2 factors of -10 that give you a sum of -3. We're looking for 2 factors of -10 that give you a sum of -3. So here is what we're going to do. We have -10, and we're going to look at the 2 factors. So because we have a negative number here, it just simply tells us that we're going to have a positive and a negative factor. So now we're going to look for all the possible factors of -10, and that's going to be, we have -1 and +10, we have +1 and -10, we have -2 and +5, and then we have +2 and -5. So those are all the possible factors that we have. And because our b, remember, b is the sum of the factors of AC. Because b is negative, it means that the negative sign is going to be on the greater factor. So all I'm going to do is any factor that has Any factor grouping where the larger number is positive, I'm just going to get rid of those. I don't need those. And now we're going to look at the last two that we have, where we have the factor with the negative sign being bigger than the one with the positive sign, and we're going to pick which of them is going to give us a sum of -3. I can see that that is going to be +2 and -5. So now we're going to rewrite our expression with our new factors replaced in the middle. So we're going to have 5x squared and then minus 5x plus 2x minus 2. So now we have rewritten that original expression, but with different factors. With the factors that make up our b, that add up to b, we replace the middle term with those factors. So now what we're going to do is factor by grouping. Okay, thanks for the response. So let's factor by grouping and see where that takes us. Let's factor by grouping, see where it takes us. So I'm going to create this group right here, and I'm going to create this group right here. You could actually include the positive sign here. That helps. That makes it easier. So now we're going to, for each of these groups, we're going to factor each of these groups. Now what that means for us is 5x squared minus 5x. Let's look for a greatest common factor of those two terms, and we can see that that is most likely going to be 5x. And then you're going to divide each of these terms by 5x, and you're going to have x minus 1 here. And then now you have 2x minus 2. We need to find the greatest common factor of those two terms. That's going to give us 2, simply because we have 2 here and 2 here, but we have x here, and this is a constant. So 2x cannot be our greatest common factor. So this is going to be plus 2, and then you divide each term by 2, and you're going to have x minus 1. So now we have a new greatest common, we have the greatest common factor of the whole expression is going to be x minus 1. So x minus 1 is our greatest common factor. And also, when we get out the greatest common factor, we combine the other factors together, and you're going to get 5x plus 2. Now, something that I want you to also note is that it doesn't matter the way you arrange the factors, you will get to the same answer. So I'm going to redo this portion here by switching the position of -5 and +2. So what I'm going to do in that case is I'm going to replace this with 5x squared plus 2x minus 5x minus 2. And now we are going to also group. Let's group this. And this is a good habit to form because of the negative sign. If you just group this here, it gets very confusing. So it's easier to just group them this way. And so we're going to now factor each of these expressions. So here we have 5x squared plus 2x. The greatest common factor there is going to be x. And when you divide each of these terms by x, you're going to have 5x plus 2. And now whenever you have negative, it's always good to factor out the negative. So -5x minus 2, the greatest common factor here is going to be -1. And then you now have 5x plus 2. So the one way to check if your answer is correct or if you're doing it the right way, the terms in your parentheses must be exactly the same. If they're not the same, then something has gone wrong with your computation, or maybe that expression cannot be factored. You have to use a different method, maybe completing the square. So now that we have this, you can see that our greatest common factor here simply is the expression that is repeated. So that is going to be 5x plus 2. And then when we take that out, we combine all the other factors. You have x minus 1. So you can see that we have exactly the same, because although when you switch them around, you see that one of them comes first, but it doesn't really matter because with multiplication, the order of appearance doesn't make a difference. So that's how you would solve this type of quadratic expression. Okay, so I see your question. So the question is, why do you put the 2x and 5x to the equation? Okay. So what we're trying to do with this method, excuse me. What we're trying to do with this method is when we look at 3x, we just need to write 3x in a different form. And in order for us to be able to write a form that works for the whole expression, we have to pay attention to AC and B, okay? So AC is the one that leads us to the factors that we're going to use for B. In this case, AC is -10, so our factors are +2 and -5. Now what we're going to do here is we're going to say that we have +2, we can just, if I wrote it this way, for example, 5x squared minus, let's say we have, what did we have? -5 plus 2 minus 2. See, it changes the expression, but what we're looking for here is an expression that can replace this right here. And the only expression that makes sense from our list of expressions is going to be 2x and -5x. So some may tell you there's another method there's another way you can look at it also, which is to actually just multiply the first term and the last term. Some others use that method. So if you multiply the first term and the last term, you get -10x squared. And what you're going to do then is you're going to look for all the possible factors of -10x squared that give you a sum of -3x. So that's another method. For others prefer that method. To me, it doesn't make a lot of difference, but if this is the method that works for you, we can go through it. So -10x squared is going to be the same as 2x, +2x multiplied by -5x. So instead of having your -3x, you're going to replace with these two factors. That's why we actually do the replacement. Then when we do the replacement, then we factor by grouping right after that. Does that is it clearer? Okay, I'll wait on your response and then let's go over to the next one. So we're going to use the box method in this case. The box method is actually similar to the greatest common factor method. They're quite similar. So with the box method, we still have, like I said earlier, everything with quadratics always starts with ax squared. Okay, I'll show you the box method. You may not like the greatest common factor method. The box method may work better for you. So let's keep walking through, and one of the things we're going to do is I'm going to show you different methods. Most of the time, your teacher will not force you into any method, as long as you find one that works for you. So I'll show you the box method with those type of expressions, and then I think that will probably work easier it'll be probably easier for you. So let's go with the box method. We still have our ax squared plus bx plus c. And so we're going to have our a equal to 1, a equal to 1, b is equal to 6, and then c is equal to 8. So we're going to draw a square or a rectangle, whichever one, however you want to call it. Whichever one you want to draw is fine. So we're just going to draw something with four boxes in it, a big box with 4 boxes in it. Or you draw a rectangle and divide it into four equal squares or rectangles. So what you're going to do here is you're going to write your first term here. This is going to be x squared. Let me actually use a different color here. And then this is going to be 8. So now with the box method, what you actually do is you're going to multiply this term and this term together. So it's going to be 8x squared. So that's going to give us x squared multiplied by 8. So we're multiplying this first term and the last term together. And then we're going to look for the factors of 8x squared that give you a sum of 6x. So we're going to have possibilities are 1x and 8x. That's probably not going to work. We have 2x and 4x. So 2x and 4x will work. So we can simply have 4x here, and then we have 2x here. So what we're going to do now is we're going to factor across each of these. We're going to factor each row. Factor each row. So now when we factor each row, x squared and 4x, what are the factors of x squared and 4x? We simply say that is x. So that is going to be x. And then when you divide each of these terms by x, you're going to have x and plus 4. And then the bottom row also, you're going to factor the bottom row. And what do you get? The greatest common factor here is going to be 2. So I'm going to just simply say plus 2. And then we divide each of these terms by plus 2. You have x plus 4. So you can see that we have the same concept of the greatest common factor method. So you can see here that x plus 4, you can see it on the top here and on the bottom. So that is going to be kind of like your greatest common factor, x plus 4. And then we combine these together, and that is going to give you x plus 2. So this is an easier example. So we're going to try one that I think is going to be a bit more challenging, more related to the one that we were talking about earlier. And then I think that should help quite a bit. So now we have 28x squared plus x minus 2. So let's go ahead and we're going to focus on the first term here and then the last term. So we're going to have 28x squared multiplied by negative 2. So that is going to give us negative 56x squared. So we're going to look for the two factors of negative 56x squared that will give us a sum of 1x. So let's go ahead and see what we can come up with. I'm going to have, because it's negative 56, that means I'm going to have a positive and a negative factor. So this is going to give me negative 56x and 1x. After a while, you don't even have to do all of this listing. But if I look at this, I'll most likely say, because I'm looking for a sum of positive 1, I'm just going to deal with 7 and 8 because nothing else gives you positive 1 in any way you compute it. So you're going to have 7x and negative 8x, or you can have negative 7x and 8x. So now we have to decide which of them we're going to select. Remember, this middle term here is positive, so we're going to try to add each of this and see which one of them is going to give us a positive value. So if you look at this, the negative sign is on the larger value, so this is going to be negative. And so we already know that this is going to be our group right here. So now let's go ahead and draw a box. We're going to draw our box. This is all this method is about. It's really about this box right here. So we're going to add this first term here comes in the top left box. So 28x squared. And then the last term comes in the bottom right box. This is negative 2. So now we have decided that negative 7x and positive 8x are our factors. So I'm just going to write negative 7x here, and then I'm going to write positive 8x over here. Now we'll go ahead and factor each row. Let's factor each row. The goal of factoring is to see if we can have we're going to have a common factor that could become our greatest common factor. So if we look here, I can just tell you that this is going to be 7x. If I divide each term by 7x, I'm going to end up with 4x here and then minus 1 here. And then I'm going to also factor this, and I can have most likely going to end up with 2. And then if you divide each of these terms by 2, you're going to have 4x and negative 1 here. So you can see that this value here and this value are the same. So conceptually, you can see them as your greatest common factor. So you're going to now put them out here. This is going to be 4x minus 1. And then whatever is on this, you're going to add the values on the outside here. You're going to bring them together. So this is 2 here, but we should actually have it as positive 2. So we can bring them together. This is going to give us 7x plus 2. So Adeze, does this make more sense to you? This approach, does this work better for you? Because I know sometimes the greatest common factor method can be confusing, but the box method it's more of a visual representation of the greatest common factor method. If you want me to go over this again, I will. Actually, let me just walk you through the steps again, and then we'll go over to the next set of examples. So what we're doing here, the first thing we're doing here is to multiply the first term and the third term, or you can call it the last term, because usually in quadratic expressions you have 3 terms. You have no more than 3 terms. So you're going to have the first term and the last term, you multiply them together, that gives you negative 56x squared. And then we look at the middle term here, it's positive 1x. So we're going to look for factors of negative 56x squared that will give us a sum of positive 1x. And if you look at this here, we can see that negative 7x and 8x are going to add up to 1x. So we're going to first, when we create our box, we're going to put our quadratic term here and our constant term here. And we're going to replace this positive x here with these 2 factors. And what we do here is we put them in different cells and then we just factor across. What we want to make sure is that the factor up here and the factor down here are exactly the same. If the factors are the same, then we have done a good job with the box. Or it's possible that you've done a good job, but you just cannot factor the expression because you can't create a common factor here. So what you're going to do now is this common factor here, you're going to bring it out, and then you're just going to combine the other factor here, 7x and plus 2. So you're going to have 4x minus 1, 7x plus 2. So that's how you would do this. Okay, are there any more questions on this specific method? All right, let's go to the next one. We'll go to the next one here. So we're going to solve by factoring. When we have to solve by factoring, the first thing we're going to do, because it's an equation, we have to always, before you can solve any quadratic equation, you have to always make sure it starts off in this form: ax squared plus bx plus c equal to 0. 0 has to be on the right hand side all the time. So what we have here is we cannot factor this directly. We have to rearrange by moving the x to the left hand side. So we cannot, let me just repeat, because this equation here is not in this format, we cannot factor it directly. We have to rewrite it so that it looks like this. And so what we're going to have with that is x squared minus x minus 12 equal to 0. So now we have this in a form that we can factor. So now we're going to factor this, and let's go ahead, because the coefficient of the quadratic term is 1, let's open up our parentheses. Open up our parentheses equal to 0. So we're going to go ahead and we have negative 12, and we need to find the factors of negative 12 that give you a sum of negative 1. I'm just going to deal with 3 and 4. 3, 4, so I'm going to put a negative here, and then I'm going to put a negative on the other one. So you can see that this one most likely is going to give you a negative 1 as the sum. So we're going to have x on this side, x on this side. We have minus 4 here, we have plus 3 here. And so this is going to be our factor. Now here is what happens in this case. When we have 2 numbers and the product of 2 numbers is equal to 0, so let's assume we have this number a and another number b, and their product equal to 0. Here are 2 possibilities. You either have a equal to 0, or you can have b equal to 0 for this to work. So now we're going to do the same thing. Simply put, we're going to take turns making each of these factors equal to 0, and then we're going to solve for x. So now we're going to have x minus 4 equal to 0. We're going to add 4 to both sides. So x equal to 4. Now we're going to x plus 3 is going to take turns being equal to 0. So x plus 3 equal to 0. We subtract 3, subtract 3. So x equal to negative 3. So therefore, x is going to be equal to negative 3. It also could be equal to 4. So those are your values of x. Any questions? Any questions on this so far? We're going to get to a quadratic formula. I know most students like that. It's a lot easier to manage. It's just substituting a bunch of values in an equation and solving the equation. So let's go to the next one. The next one is 2x squared plus 7x plus 3 equal to 0. So I'm going to use the box method here because I think that's probably what may be easier to understand. So I'm just going to multiply 2x squared and 3. That's going to give me 6x squared. And then I'm going to find the factors. I'm going to find the factors of 6x squared that will give you a sum of 7. So we can have x and 6x. So just looking at that, I can see that x plus 6x is going to be 7x. So let's go ahead and draw a box and divide it into 4 equal parts. Divide it to 4 equal parts. So our first term, which is our quadratic term, is going to come right here. So this is going to be 2x squared. Our last term, or our constant term, is going to come down here. That's going to give us 3. And now our factors, we're going to just put them in the remaining boxes. Now we're going to go ahead and factor across, factor across. So let's go ahead and factor each of these rows. So 2x squared and x, we're going to just find that the common factor there is going to be x, and then we're going to divide each of these terms by x. We have 2x and then plus 1. And then we're going to factor the bottom row as well. The common factor, the greatest common factor is going to be 3. We divide each of these terms by 3. We have 2x and plus 1. So you can see here that we have a greatest common factor here because they are repeated. So now we're going to have 2x plus 1, 2x plus 1, and then we're going to combine the other factors. It's going to be x plus 3. This is equal to 0. And like I showed you earlier, if you have a multiplied by b equal to 0, it means that a could be 0 or b could be 0. Simply put, we're going to take turns making each of these factors equal to 0. So we have 2x plus 1 equal to 0, and then we subtract 1 and subtract 1 from both sides. So 2x equal to negative 1, divide by 2, and then we have x equal to negative 1/2. And then we're going to now have x plus 3 equal to 0. We subtract 3 from both sides, so x equal to negative 3. So therefore, for this quadratic equation, the values of x are going to be negative 3 or negative 1/2. So that is the solution to this equation. Are there any questions? Please feel free to ask questions. Don't feel shy or don't be intimidated by anybody else. Just ask your questions. I want to make sure our goal, really, all of what we're doing right now is because we have a goal to help 5,000 students across this country and across the globe actually do very well in math at the end of this school year. We want their grades to improve. If you had a B last school year, we want to help you get to an A at the end of this school year. And if you had a D, we still believe you can make it an A this school year if you follow the methods and the techniques that we're going to be sharing with you. So feel free to ask questions. This is really for you, and we're trying to serve you with this. Okay, so we're going to go to I'm going through a lot of this because of some of our students that are getting ready for the SAT or the ACT, and some of the students that are actually about to get into Algebra 2 as well. And this is a topic that you have to really understand to be successful in your Algebra 2 class. So I want to make sure that you do very well in your schoolwork as well as your exams. So now we're going to the next question, and now we're going to be looking at the quadratic formula. The quadratic formula is pretty easy to use, and we always start from ax squared plus bx plus c equal to 0. So what we're going to do now is I'm going to write that for you as the standard quadratic equation, but here's your quadratic formula. X equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So what we're going to do first is we're going to compare the equation we have, which is this one right here. We're going to compare it with our standard quadratic equation to get the values of a, b, and c. So with that in mind, we know that a is going to be 1, b is equal to negative 4, and c is equal to negative 32. So now that we have the values of a, b, and c, we're going to now substitute them into the quadratic formula. So most students like this because you don't have to worry about factoring. So if you don't even remember how to factor, you can use this. And the benefit of this formula especially is that some equations that cannot be factored, you can use this to get a value for your x. You can use this to get your x values. So now that we have our values of a, b, and c, we're going to simply substitute. So x is going to be equal to negative b. So what I like to do is I like to just substitute directly, and I'm not going to make any kind of, I'm not going to jump any steps. I'm just going to show you how to work this formula. So negative b is going to be negative of, and then b is actually negative 4. A common mistake that students make in this is because this is a negative number, because b is a negative number right here, they actually just ignore this negative. But what we're doing here is we're going to have negative, and then whatever the value of b is replaced in here. So this is going to be negative 4 plus or minus the square root of b squared, negative 4 squared, minus 4, a is 1, and then c is negative 32. And then we divide by 2a, 2 multiplied by 1. Be sure to not forget this 2a, because I've seen instances where students just write 2 all the time, but you have to make sure that you're accounting for the value of a. And I think in the next example we will see why that's important. And so now we're going to simplify. So negative 4 is going to be positive 4. So this is going to be positive 4. And then we have plus or minus square root of negative 4 squared is going to be 16, because that simply means negative 4 multiplied by negative 4, that is 16. Then minus 4 or negative 4 multiplied by 1 multiplied by negative 32. So negative is going to be positive. So this is going to be plus 128. And then we're going to divide this by 2. So this is going to be 4 plus or minus the square root of 144 over 2, which is going to be 4 plus or minus 12 divided by 2. So now we have two instances. We have x equal to 4 plus 12 divided by 2. X is also equal to 4 minus 12 divided by 2. Whenever you see plus minus here, it's just telling you that there's a possibility that you're going to have two values for the variable. So this is going to be 16 divided by 2. This is going to be negative 8 divided by 2. So here x equal to 8, and here x equal to negative 4. So you can simply say that x is going to be equal to negative 4 and 8. Okay, I see there's a question about linear equations and functions. If you can give me a little bit more specificity, or just be a little bit more specific on what you need, I'll try to bring it into what we're working on. Okay, so that's that. So let's go to the next one. The next one is another. Okay, so this is very important, and we have to start with. Whenever you have a quadratic equation, this is your gold standard. Ax squared plus bx plus c equal to 0. So you want to start with this standard equation. And so, Michael, if you give me some more specifics on what you need, I will actually work with I'll work on some problems that relate to what you're interested in right after this question. So I see a request for set and interval notation with regard to domain range, most likely. So we'll get to that right after this. Let's finish this one and then we'll get to that. So we have let's see. Okay, so we have to rewrite this equation so it looks exactly like this. And that simply means we're going to move all. Remember, on the right hand side, everything has to be 0. You can only have 0 on the right hand side. So if we don't have zeros, we have to move everything to the left hand side. So what I'm going to do is we're going to have 5x squared, and then we're going to move 2x over minus 2x squared. We have minus 8x, and then we have negative 13x. We move it over, plus 13x, then minus 40. We have negative 32, we move it over, plus 32 equal to 0. So that's what we're going to do, and I wrote it this way so you can see that all the common terms are grouped together so we can simplify a lot more easily. So we have 5x squared minus 2x squared. That's going to give us 3x squared. Negative 8x plus 13x is going to give us plus 5x. And then negative 40 plus 32, we have negative 8 equal to 0. So now we have our equation in the desired format. So we can see that it's in this form. So now let's go ahead and get the values of a, b, and c. A is equal to 3, b is equal to 5, and c equal to negative 8. C equal to negative 8. So now let's go ahead and substitute all these values into our quadratic formula, which is x equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to go ahead and do that substitution. So x equal to negative 5 plus or minus the square root of 5 squared minus 4a is 3 and c is negative 8 divided by 2a. Remember here, a is not 1, so we have to account for that. 2 multiplied by 3. So this is going to be negative 5 plus or minus the square root of 5 squared is 25. Negative 4 multiplied by 3 multiplied by negative 8. 4 multiplied by 3, 12. Multiplied by 8, 96. So it's going to be positive. So plus 96 divided by 6. So we now have negative 5 plus or minus square root of, we add this together, we should get 121 divided by 6. And so we're going to have x equal to negative 5 plus or minus 11 over 6. So we have two possible choices here. We have two possible answers because we have a plus here and we have a minus. So we have to write it this way. X equal to negative 5 plus 11 over 6. We also have x equal to negative 5 minus 11 over 6. So this is going to give us 6 over 6. This is going to give us negative 16 over 6. So we now have x equal to 1 in this case, and here we have x equal to negative 8 over 3. Whenever you're dealing with quadratic expressions, you don't have to convert any fractions to mixed numbers. It's really not that important. So what we're going to do here is we now have our values, x equal to negative 8 over 3, and we have x equal to 1 as well. So these are your two values of x, so I'm going to help address questions related to set notation with regard to domain and range. So let me get some graphs that we're going to work with, and let's get some graphs. So we're looking at set notation as it relates to domain and range of functions. So let's go ahead and so there are two characters that you want to use whenever you're dealing with domain and range. You have the parentheses, and we have the square brackets. The parentheses simply means that the value that you are considering does not really belong in the function. It's not an actual value in the function, and I'll show you some examples. So this is going to be not an actual value, then this here represents an actual value. So one thing to know about the parentheses is every time you have infinity, infinity is always negative infinity, positive infinity. Always, anytime you have infinity, it's always going to be the parentheses. You're always going to have parentheses because infinity doesn't exist as an actual number. It's just an indication of something that doesn't really end. So what we're going to do now is I'm going to get some graphs, and we're going to just throw the graphs on the screen, and we're going to try to find the domain and the range of those functions. So give me a second. Let me grab some graphs. I could actually draw a few on my own. So let's see. Let me draw some here. Let's draw some here, and I'll just put some values on the graph. So if I have a graph that looks like this, and it's going in this direction, going in that direction. So if you want to find the domain, always remember your domain represents the values on the x-axis, and your range represents the values on the y-axis. And then your arrows, very important, your arrows means that it continues in those directions. And we have this simply means that this graph continues in that direction, and then this arrow means it continues in this direction. So now what we're going to do is, the simplest way to go about this actually is to look at the possible values of x. If I kept going this way, you can simply try to draw the graph up to the x-axis, and you can see that as you continue to go this way, you're going to approach negative infinity, which simply means it doesn't end, but you're going towards the negative side of the number line. Then if you look up here, you keep going, you try to see if you can draw it down to the x-axis, and you can see that the further you go up here, the more you're going to trend towards a positive infinity. So that simply means that we have a positive value, but we don't know where it ends, because this simply means that the graph does not end. So that's how you walk through a problem like that. Now let's do something unique. I'm going to do this right here. Let's make this -3. I'm going to draw an open circle here, and I'm going to go that way. So in this case, what we're going to be looking at, we have a stopping point. So the graph does not go past -3. When you look at this, the graph does not go past this point right here. But on this side here, the right hand side, you can see that the graph continues in perpetuity. So it just doesn't stop. So what you're going to now ask yourself is, which of these am I going to use? We're going to pay attention to this open circle right here. Whenever you see an open circle on the number line, it means that that point that is represented is actually not a valid point on the graph. It's not part of your domain or your range. It will not be a part of your domain or your range. So what you're going to do now, in this case, is because you're starting off at -3 and that's where your open circle is, you're going to have your parentheses, -3. And then we're going, if we keep going here, if you keep going in this direction and you draw this way to the x-axis, you're going to see that you're approaching positive infinity. We don't have to put a plus. Some people do put the plus sign, but it's not really required. So that is the domain for each of these graphs. That is the domain. And here we're going to have, let's make this -1. So now let's go for the range. The range is the same method. What we're going to do now is look at the graph, but instead of drawing a dotted line to the x-axis, we're going to draw a dotted line to the y-axis. So if you look at this, the more, look at this right here, as we continue to go down this way, our range is going towards -infinity on the y-axis. And then as we continue to go up this way, and then we draw to the y-axis, you can see that as we continue to go, we're going much higher. So it's most likely going to trend towards positive infinity. So this is one of the easy ones. Now let's go to this right here. So if you look at this open circle, we actually, if we draw it up here to the graph, it's -3. But when we draw it to the y, it's going to be -1. And because it's an open circle, in your range, you're going to have -1. -1, let me write it properly so you can understand, you can read it. So in that case, you're going to have -1. And that -1, because it's an open circle, we're going to use the parenthesis, which shows that it's actually not a value on your range. And then we're going to keep going this way. As we go up this way and you plot it to the y-axis, you're going to see that it continues to increase. So this is going to be positive infinity. So that is how you will get your domain and your range in this case. Now let's go for let's do something else that will I'm going to do a quadratic one, because I think you may be also asking about quadratic, and I'll go to a linear. I think the question here is, with the elimination equations, how do you do that? Because sometimes I get the wrong answer. Okay, and you need a little review on function notation. Okay, no problem. So here, what we have, I'm going to draw a quadratic equation. And so let me just draw a rough sketch of a quadratic equation. I'm going to put an open circle here. I'm going to put an arrow here. I'm also going to come over here. Let me use that. And I'm going to come over here. And I'm going to put some open circles there just so we can show some more complicated types. Open circle here. Okay. So we have, let me label them. So let's go here. This is going to be about -6. Let's make these 5. Here we're going to have -2. Let's make this -1. And here make this 2. And let's make this 5. Okay, so now we have 3 open circles. What we're going to now do is we're going to start from the first open circle. Remember what I said earlier, whenever you have an open circle, it means that the domain and the range, the x and y values at that point are actually not part of your domain and your range. That's why they are open circle. So what we're going to do is, let's look at that point right here. We're going to start with the domain. So we have this point here is going to be, let's call this negative 6, 5. That's the point. So negative 6 is our domain, but because of the open circle, we're going to just put a parenthesis out here, negative 6. And we continue to go all the way to this point right here. So what happens here is we have an open circle, which means that negative 2 is also not on your domain. So this is going to be negative 2. So we have accounted for this from this point here to this point. So we have negative 6 all the way to negative 2. It simply means that negative 6 and negative 2 are not on your domain, but every number between negative 6 to negative 2 is on your domain. And that's what that means. Now we have a problem. So we've closed out the parenthesis. What do we do next? That's where your set, this is why the set notation is important. We're going to come with union, which means a combination. So it means that we can continue to combine. So we have little parts, we're combining them together. So we start off here also from negative 2, because that's where we're going to start off here. But negative 2 is actually not a point on your domain. And then we go all the way up here and we get to positive 5. So this is going to be positive 5. And then we're going to union again, because we have to account for this last part of the graph, which is going to be, this is union, and then we have 5, and then we go all the way to infinity, because if you continue to go in this direction and you draw it down, you're going to see that you're going to keep going towards the positive value of x, towards infinity. And this arrow simply means it doesn't end, so you're safe to say this is going to be infinity. So this is going to be your domain for this function right here. Now let's look at our range. The range goes through the same kind of method. You go through the same strategy as you approach the range. So now let's look at the range. From here we go to, the range here is going to be 5. So we have 5, 2, and then we go over here. Our range is negative 1, negative 1. And then we want to start from negative 1 as well, but we have to combine. So this is union. And then we have negative 1 all the way through to 2. Don't make a mistake of drawing it down to the x-axis. It's a common error that students make. But just remember, when you're dealing with the range, everything is to the y-axis. So this is going to go all the way to 2. And then we union this. And then we now go from here to the end. We're going to have 2 to infinity, because this graph continues forever. And when you keep dragging it, when you keep drawing a dotted line to the y-axis, you're going to see it keeps increasing forever. So in this case, this is your domain and this is your range. So I hope this has helped clear it a bit. I know there's a whole lot more to it. There are lots of different types of examples that we could do, but I wanted to make sure that we did a simple one, a medium one, and one that actually is a bit more challenging. There are other things we could have done to, there are other examples that are available. So if you go to our channel, there we have some videos on this topic, so it should really be helpful to you. What I want to do is I want to actually attend to the question on elimination. You're looking at, I'll take it you're looking at system of equations, correct? You may learn about union in Algebra 2. If you're in Algebra 2, you may learn about union in Algebra 2. But sometimes it's taught in Algebra 1. Okay, so we're looking at system of equations and we want to use elimination. So let's go ahead and do some systems that require elimination. I'm going to try to find some examples so I don't have to make up something that will not work. Okay, you're in Algebra 2. I'm sure you'll get to it. And as we walk through this, as we do these sessions, you just let me know if there's any part of it you don't understand. If you want, you can actually send, you can email an example of a question you would like for us to walk through, and I'll be glad to do that during this session. So let's quickly look at some system of equations, and I want to get some systems of linear equations, something that is going to lead us to elimination, and we'll be able to do that for you shortly. Okay, all right, let's get this one. we have a system here. The system here is 2x plus y. 2x plus y is equal to 9. Actually, I don't like that one because you can easily, well, that's fine. 2x plus y equal to 9. And then we have 3x minus y equal to 16. So we're going to start simple. Maybe we'll do 2 or 3 elimination problems, and I think that should be it for today, and then we can pick it up again next time. So now we have y. This you can actually use substitution, but for the sake of elimination, let's go about it this way. So what we're looking for is to, when we want to eliminate, we're trying to make one of those variables 0 when we add the 2 equations together. So we're going to try to add the equations together and make sure one of the variables is zeroed out. That's really what elimination is about. So here I can see that positive y and negative y, if I add them together, I'm going to get a 0. So all we're going to do here is add these 2 equations together. Let's put a plus sign here. So we have 2x plus 3x is going to be 5x. Positive y plus negative y is going to be 0. So I'm just not going to bother. Or we can say plus 0 equal to 9 plus 16. This is going to be equal to 25. 25. So now 5x is equal to 25. And then we divide by 5. And then x equal to 5. So now that we've eliminated, we've got a value for x, we can just pick any of these equations and then substitute that value back in. So we're going to have 2, I'm going to use this equation, it looks easy. 2 and then x is 5 plus y equal to 9. And so we have 10 plus y equal to 9. Let's subtract 10 from both sides. And we have y equal to negative 1. So here we have x equal to 5, y equal to negative 1. And most teachers like you to express it as a coordinate point. So you would write it this way, 5, negative 1, as the solution to your equation. Let's get one that is not as simple. I hope this one makes sense. I hope it makes sense. But let's get one that is not as straightforward. And I think that one should help. Okay, let's get, I think I've seen one that I like. Okay, so we're going to go with 2x minus y equal to 9, and then 3x plus 4y equal to negative 14. So what we're going to do here is we're going to decide which of them we would like to eliminate. And personally, I would eliminate y, but you can also eliminate x. So in order to eliminate, what you're going to do actually is you're going to find the greatest common factor of those two terms. So if you're going to eliminate x, you need to find the least common multiple of 2x and 3x. You have to find the least common multiple of 2x and 3x. Simply put, if you're not sure how to work the LCM with algebra, what you can simply do is this. You look at the coefficient here, look at this number to the left here of x. What you can do is look at the number on this second equation, which is 3. So you're going to multiply this one by 3, and then multiply this one by 2. That way you're going to get 6x here, you're going to get 6x here. That's your goal, because you have 2 and 3. So what we're going to do now is we have 6x minus 3y equal to 27. And here we have 6x plus 8y equal to negative 28. So now you have two choices. I'll tell you the way that a lot of teachers teach it is to make sure that you have opposite signs. I don't think you have to. And let me show you why I don't think you have to. So here's what I would do. I need to eliminate x. So what do I need to do? I have 6x here and I have 6x here. I can simply subtract because that will give me 0 on this side. So that's going to give me 0. and then I have negative 3 minus 8. That's going to give me negative 11y, and then I have 27 minus negative 28, which is 27 plus 28, and that will give you 55. That will give you 55. So you have negative 11y is equal to 55, and then you divide both sides by negative 11, and you have y equal to negative 5. And like I said earlier, all you're going to do now is take the value of y equal to negative 5, and you're going to substitute in any one of them you like. I'm going to pick the first one. It looks pretty simple. One of the things I want you to do when you're dealing with math, just simplify it for yourself. Don't go make it too complicated. So you're going to now have y equal to negative 5. So I'm going to have 2x minus negative 5 equal to 9. So I have 2x plus 5 equal to 9. Subtract 5 from both sides. I have 2x equal to 4. And I can divide both sides by 2. And then x equal to 2. So we have x equal to 2, y equal to negative 5. So we're left with 2, negative 5 as that point. This is very important, especially for those of you that are really working towards the SAT and the ACT. It's rare for them to write your answer in this format. Most likely, this is what they typically want to do. And beware of something like this, negative 5, 2. Because they're going to have that as a possible choice. So you have to pay a lot of attention to what you're doing when you're doing those type of questions. And because sometimes it's possible that you want to eliminate x first and then get y, or you want to eliminate, like in this case, we got value of y first before we got the value of x. Make it a habit to write your x value first, so that when you're in a hurry, you don't make a mistake of switching your x and y values. Okay, so is there any other topic you guys like me to walk through before we end the session? If there's any other topic you'd like for us to walk through. Actually, what I want to do, because of quadratic, let's do one word problem that has quadratic equations, and I'll show you how to manage that. Let's see, let's try this one. So the area of a rectangular pool is 1,260 square feet. Find the dimensions of the rectangle if one side of the pool is 48 feet more than 3 times the other side. If one side of the pool is 48 feet more than 3 times the other side. So let's go ahead and just draw a pool and see what we're going to work with. Okay, so we have a rectangular pool, and here I'm just going to write 1,260. Find the dimensions of the rectangle if one side of the pool, so one side of the pool is 48 feet more than 3 times. So I'm going to pick the smaller side of the pool. So just as a habit, this is what I like to do. Smaller side is going to be x, and then larger side, it says it's going to be 48 feet more than 3 times the other side. So 3 times the other side is 3x. 48 feet more is plus 48. So now we have 3x plus 48, and then we have x over here. And now we're told that the area of the pool is 1,260 square feet. So what we now have is, remember, your geometry is that area of a rectangle is length multiplied by width. So here your length is going to be 3x plus 48, and then your width is going to be x. So let's go ahead and simplify that. So we have 3x squared plus 48x. So now what we have is, we now know what the algebraic expression for the area is. Now let's go to the value of the area. So we have 3x squared plus 48x equal to 1,260. Remember, our quadratic formula is, our quadratic equation actually is ax squared plus bx plus c equal to 0. So we can't have 1,260 here. We have to move it off to the other side. So we have 3x squared plus 48x minus 1260 equal to 0. So here's something I want you to be able to see as well. You can either go ahead and use the quadratic formula and have a lot of big numbers, but if you look at each of these terms, this is 3, this is 48, this is 1260. They are all multiples of 3. So you can divide everything by 3. So let's go ahead and just draw a line, divide by 3. We're going to have x squared plus 16x minus 420 equal to 0. And if you don't like the other methods and you just like the quadratic formula, we'll go ahead and use it. X equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. So here x is going to be, let's make sure we find the values of a is equal to 1, b is equal to 16, and c is equal to negative 420. So x equal to minus b, which is minus 16, plus or minus the square root of b squared, which is 16 squared, minus 4 times 1, a, and then c is negative 420, divided by 2a, 2 multiplied by 1. So let's further simplify. So we have negative 16 plus or minus, we have square root of 16 squared is 256. 4 multiplied by 1 multiplied by negative 420. So negative is going to be positive, and this is 1680. And then we divide by 2. So 1680 plus 256. This is 6391. 1936. So negative 16 plus or minus square root of 1936 divided by 2. Now we got a problem, because it's possible that this test that you have this question, you may not be allowed to use a calculator. So let's go ahead and see if we can come up with the square root. I'm just going to go ahead and show you. I want you to understand the math behind some of these things so that you're not so reliant on the calculator. For some of you that are taking the SAT, there is a test on the SAT where you can't even use a calculator. So it's good to at least be able to understand how these things come about. So what you have is 1936. Let's divide by 2. We have 968. We divide by 2. We have 484. We divide by 2. We have 242. We divide by 2. We have 121. And we divide by 11. We have 11. So what we're going to do here is we're going to just pair them up. For you to have a square root, we're going to pair them up and then bring out a member, pair them up, bring out in a member, pair them up, bring out a member. So we're just going to multiply this together. We're going to have the square root is actually going to be 2 multiplied by 2 multiplied by 11. So we have negative 16 plus or minus 44 divided by 2. So now we have x equal to negative 16 plus 44 divided by 2. We also have x equal to negative 16 minus 44 divided by 2. So we're going to have to make some decisions when we get to this point. So x is equal to negative 16 plus 44 is 28. We divide that by 2 and we get 14. X equal to negative 60 divided by 2, which is equal to negative 30. Now we have a problem. We have two answers, but we actually need to figure out if both answers are valid or if one of them is invalid. For us to answer that question, we need to look back to the question we're actually working with. The question talks about length. It's length. Length is in feet. And the problem with length, or maybe not a problem, but something you need to know about length is a length can never be negative. So what you're going to now do is you're going to simply say that this isn't going to be a possibility for you. And so we're going to just have this as our value. So remember that the shorter side is x, which is 48. The longer side is 3x plus 40. Actually, x is 14, not 48. X is 14. So x is 14. And then 3x plus 48 is 3 multiplied by 14 plus 48. This is going to be 42 plus 48, which is equal to 90. So let's check if we actually get to 1260 when we multiply the length by the width. So 14 multiplied by 90 is going to be, I'm just going to focus on 14 multiplied by 9. So that is 6, 12, so it's 1260. So therefore, we can say our width is 14 feet and our length is 90 feet. So this is going to be the dimensions of that swimming pool. So this is how you work through word problems whenever you have to deal with quadratic equations. I had another one, but where the time is fast spent and I know you guys want to go enjoy your evening. So I hope this has been helpful to you. We're able to go through we're able to review some different ways of solving quadratic expressions, also quadratic equations. Then we did some work on the set notation for domain and range, and then we did a few systems of equations. And then finally, we did a word problem that had to do with creating a quadratic equation and solving. And the most important part about the quadratic equation is being able to identify which of them you have to eliminate. Sometimes you don't have to eliminate anything, but whenever you have to eliminate, you have to make that decision. Don't fall for thinking that all answers are valid. Not every time is your answer valid. So that's that. So thank you all for your time today. I really enjoyed your feedback and your questions, and I hope we can make this, we can do this again next week Sunday, but we'll see. Leave us some feedback. I'm going to put a poll on our Facebook page, on our YouTube channel. I'm going to create a poll that you tell us whether you want this Sunday session, and this Sunday session is just your time. I may come with a topic, and what I'm going to try to do is not just focus on 6th grade, 7th grade. I'm just going to come with a topic, and if that topic is helpful to you, you can come and ask questions related to that topic. But if you're working on something in school and it's Sunday, you're maybe trying to get some homework done and you can't get any help anywhere and we're on, just ask the question. I'll be glad to make sure we can accommodate. I try to make sure that at least I have a few topics prepared in my mind that I can answer. And so this is something that we'll keep doing. So thank you again, and have a wonderful evening. Enjoy your Labor Day weekend. Enjoy your barbecue tomorrow and family time. And you stay blessed and stay safe and continue to enjoy school. All right. Bye for now. Thank you again.
Delacimo.